Okay, so this video is meant for Algebra 2. We do have a quiz on Friday covering exponentials and a little bit of logs. So here are 7 problems to get you some extra help. Okay, so first one, we're going to graph this function. And this is an exponential function. When we graph an exponential function, I want you to find 3 points. -1, 0, and 1. Those are the x values. Now notice this graph has a transformation. That 2 in front is a transformation. So this parent function, and I'll do it over here, the parent function, is y, or f of x, it doesn't matter, y equals 3 to the x. That's the parent function, okay? So when I graph this, I need 3 points. -1, 0, and 1. And when I do that, when I plug it in, remember, -1 flips the number upside down. Anything to the 0 power is 1. And then anything to the first power is itself. And there's your 3 points. Okay? Notice also, just to kind of give you another thing, this 3, since 3 is greater than 1, this is a growth model, or a growth graph. And you'll see as it goes to the right, it grows. So when I graph this, recall that we have an asymptote on this x-axis, right? So we can't go below or go past that or touch that x-axis. And then here I'm going to mark 3. That's too small. 1, 2, 3. 1, 2, 3. 1, 2, 3. And I'll plot my graph, and I'll do it in blue dots. Okay? So -1, 1/3 is here. 0, 1 is here. 1, 3 is here. And in a blue dotted, that is the parent function. Okay? So now, what does this 2 in front do? Well, this 2 in front is going to take all of your y values and double them. So remember, we just simply times 2, times 2, times 2. This 2 in front is a vertical stretch, because 2 is greater than 1. So it stretches. So you'll see all these y values get bigger. So this becomes 2/3, 2, and 6. And now the points are, and I'll do it in red here, -1, 2/3, so just a little bit higher, 0, 2, and then 2, 6. So this is 3, 4, 5, 6. And then 1, 6. So you see now the graph goes, and let's do it here. Let me do it in purple. I'm sorry. I'll change this in purple. So -1, 2/3, 0, 2, 1, 6. And now solid, there's the graph going up faster and down quicker. And notice the asymptote doesn't change. So we're still asymptoting on the x-axis. The domain and range of this graph. So the domain are the x values. Notice that the arrows go left to right. So the x's are all real numbers. But now the range is a different story because of this asymptote. This asymptote never touches the x-axis when y is 0, and it never goes negative. So your range, your y values, y greater than 0. Okay. Next, write an exponential function to model the situation. Find each amount after the specified time. So a population of 120,000 grows 1.2% per year for 15 years. So this is growth. So growth is this formula. A equals P times 1 plus R to the T. That's what we're looking for. So in this problem, what do we know? Well, this is your P. This is your starting population. This is your R, but remember we use it as a decimal. Move this 2 places to the left, 0.012. And this is going to be my T of 15. Okay? So when I plug it in here, A equals, and now just the model itself ignores the T value. So the model itself would be this. 120,000, 1 plus 0.012 to the T. Or you could also add those 2 numbers inside together. So either one works. Okay, or. And now let's plug in 15 for t. And now let's actually find what's the population going to turn into after 15 years. And again, you can plug it in for t in either model. It doesn't matter. And when I plug this in my calculator, 120,000 times 1.012 raised to the 15th, I get something like 14,351, and we'll just go 2. And that would be people because it's a population. So 143,512 people. Okay, so there's a growth model. Next, another graph. Here we go. Let's graph this transformation. And for the sake of the test, I want to ignore this 5. So let's just say this is 1/3 x minus 8. Okay? And let's change this 8 to a 4. Okay? Alright. So if you want to rewrite this, this is y equals 1/3 to the x minus 4. So I will start with the parent function. So the parent function again is going to be y equals 1/3 to the x. And I will pick 3 x values, the standard x values of -1, 0, and 1. And when I plug them in, -1 flips that number, 0 as an exponent gives you 1, and anything to the first power is the number itself, 1/3. So we'll graph this again. Let's go 3 in every direction. And now we do have an asymptote here on the x-axis. And I'll graph this in red. We'll do it in red. So -1, 1/3, 0, 1, 1, 3. And I'll make it dotted. Okay, and it just goes towards that asymptote, never touches. And now we have this -4. What does that -4 do? That's a vertical shift, not a stretch or shrink, a shift. That means go down 4. So on my graph, I'm simply going to take everything and shift it down 4. And this includes the asymptote. I shift it down 4. So notice, this asymptote goes down 4. 1, 2, 3, 4. And now all these points go down 4. So this is -1, 1/3. So 1, 2, 3, 4, just above that asymptote. This is 0, 1, 1, 2, 3, 4. And this is 1, 3, 1, 2, 3, 1, 2, 3, 4. And there is the new graph. That's bad at the end there. Hold on. Okay. So it's going towards the asymptote. Oh, stop. I made a mistake. I am so sorry. I went through this problem and made a mistake. Look here. Look. This is -1, 3. Okay? We need to fix this. I'm sorry. Erase this graph. Okay? Erase the graph. Everything else is good. Just erase the graph. So on this graph here, okay, we need to reverse this. Oh shoot, sorry. I'm gonna do a lot of erasing. Okay. So back to plotting the points, because I didn't plot them right? This is -1, 3. I apologize. -1, 3, 0, 1, and 1, 1/3. There's the parent graph. So, you know, the reason I knew that is because I looked at the b value. This b value is 1/3. 1/3 is less than 1, so I knew it was decay. It wasn't supposed to grow, and our graph was growing. Okay, so again, you know, good mess up, right? Because you get to explain the difference between growth and decay and how the graph represents that. Okay, so now, again, I'll focus on this -4, which means go down 4. So I'm going to take everything down 4, including the asymptote. So that makes me include another y-axis mark down here. So I can go 1, 2, 3, 4 down. So there's my new asymptote, and now all these points move down 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And now there's that, and it goes towards the asymptote that way. And there's the shifted graph. Okay, so I apologize for the screw up. So now domain and range. So again, left and right arrows. Domain is all real numbers. But now the range, okay, so notice the asymptote moved down. So now this y value here would be 4, and it can't go below. So now your range is y is greater than negative 4. Can't be negative 4. Can't be negative 4, and it can't go below. So y is greater than negative 4. Alright, good. So again, sorry about the mess up. Glad I caught it. 4 here. Alright. What's it say to do? Find the amount in a continuously, okay, this word should mean something. Continuously compounded account for the following conditions. Principal, interest rate, time. When you see that word continuously, you should identify this equation. A equals PE to the RT. Okay? So, what do they give me? Principal, interest rate 0.076, and time. Remember that E is a function in your calculator. Use your calculator. A equals 400 E to the 0.076 times 1.5. And we just simply plug in our calculator. 400. Remember that E, to get E, remember E is second ln. Right? So second ln will give you the E. So 400, second ln for the E, 400 E to the 0.076 times 1.5. And this is money, so let's round to 2 decimals, and I got $448.30. Okay? So again, notice the interest here, the interest earned is what is additional to the original principal. So that would be $48.30. Cool. Alright, 3 more. Now we're moving on to log country. Here we go. Evaluate each logarithm. Alright, so we have 2. We'll start with, we'll call them A and B. So A. Log base 4 of 8 equals something. Question mark x, I don't care. Rewrite this in exponential form. So we're going to rewrite this using exponents. To do that, identify the base 4 and the exponent, which is your question mark. The base 4 to some power equals the third number 8. And now, 4 cannot be written to some power of 8, and 8, you know, they don't have the same base, but we can find the same base, right? So one of them is not the other base. 4 is 2 squared. 8 is 2 cubed. So now, notice the bases. These are 2 and 2. So now the exponents have to match up. Well, this question mark is not 3. 2 times the question mark is 3. So divide by 2. And the question mark, the answer is 3/2 or 1.5. And remember the check, right? So the check is, so to check that, raise 4 to the 3/2 or the 1.5 power, and you will get 8 in your calculator. So you can always check using the calculator. Okay, let's do B now. B says log of 10,000. And now this log doesn't have a base with it, but you should know that the base is 10. And we need to know what this is. Now, your calculator can do it because it's base 10, but I don't want to do it that way. I want to use my brain. So I'm going to rewrite it using exponentials. 10 is the base. The question mark is the exponent. 10 to the question mark equals 10,000. So now, 10,000 can be written as 10 to some power. So what is 10,000? Well, 10,000 is 10 to the 4th. a 1 with 4 zeros. And now, we know that the question mark is 4. Alright, good. So be aware of how you can rewrite logs into exponential form. Very important. 6. In 1812, an earthquake of magnitude 7.9 shook New Madrid, Missouri. Compare the intensity level of that earthquake to the intensity level of the earthquake below. And we have a magnitude of 9.5 in Valdivia, Chile in 1960. Okay. All right. So I'm going to take the bigger number first. So this number right here, this 9.5, because it's a bigger magnitude, that's going to be my M1. So then 7.9 would be my M2. So we are comparing the Chile, the earthquake in Chile to the earthquake in Missouri. So we are comparing 1960's earthquake to the 1812 earthquake. So we just use this formula, and it'll be given to you. So we have log of the intensity. And remember, we never find out what these i's are. It's just this is the comparison of the intensity. And and we're going to take, so the higher one, 9.5, minus the smaller one, 7.9. And we will get that right side. And that comes out to be 1.6. And now we'll use the fact, okay, this is base 10, so rewrite this using exponential form. 10 is my base, and 1.6, the answer to your log problem, is your exponent. So 10 to the 1.6 equals the comparison of your intensities. And we'll do 10.6, or 10 raised to the 1.6. And what I get here is I get that the comparison of the intensities is around 39.8. So what this is telling you is comparing the earthquake in Chile to the earthquake in Missouri. The earthquake in Chile was 39.8 times more intense. Okay? So the earthquake in Chile was 39.8 times more intense. And I'm starting to write this terribly. Than the earthquake in Missouri. So the earthquake in Chile was 39.8 times more intense than the earthquake in Missouri. Okay. So remember, compare the bigger one to the smaller one. All right, last one here. Okay, let's graph a log. It says describe how the graph of each function compares to the graph of the parent function. And again, we're going to graph this ourselves. Okay. So the parent function for this log graph is y equals log base 7 of x. But remember, we cannot think about the log graph right away. The first thing we think about is its inverse. So this is the parent graph. Well, the inverse graph is y equals 7 to the x. It's the exponential. Let's find the 3 points that go with this exponential using those 3 x values of -1, 0, and 1. Remember, -1 flips the number upside down. 0 as an exponent gives you 1, and anything to the first power is itself, 7. And now, let's do the parent function. And now we look at the parent function of y equals log base 7 of x, and we say, okay, so to get from the inverse to its other function, we simply switch x and y. 1/7 -1, 1 0, 7 1. And there are my 3 points. I'll go 7 in all directions. And I'll graph these 3 points in red. So we have 1/7 -1, so that's really close. 1, 0, and 7, 1. And we have an asymptote. Remember, now it's the y-axis that is an asymptote. Okay? And there we go. So that's the parent function. And now, what does this minus 2 do? Well, that minus 2 is with the x. It's a horizontal shift. Horizontally, you do the opposite. That's going to shift everything to the right 2. So I'm going to take my 3 points and shift them to the right 2, including the asymptote, which shifts to the right 2. So now, the asymptote is at 2. This point goes here now. This point shifts to here. And this point right here, let's add a couple tick marks. I'll add them in blue. Right there. And this is the final answer. Everything just shifted to the right 2. And now what happens to your domain and range? Well, the domain here, notice the arrows don't go left and right. This arrow is going straight down. This arrow is going to the right. It's stopped by this asymptote. This asymptote is when x is 2. X cannot be 2, and x cannot be less than 2. X must be greater than 2. But the range, this time, y can go down, and y can go up. All real numbers. Alright, very good. So thanks for watching. Bring this in for your bonus points, and hopefully you do well on this quiz Friday. Thanks again. We'll see you Friday.